To get started on Git, who here has less than like 3 months of experience with Git? So started sometime this summer? All right, so I'm going to try and start from the very basics and then go through things like branching, merging, and rebasing. So if I'm going too fast, please like throw your hands in the air, make me go back. Let's talk about it. I may tell you that we're going to do a breakout session to go deeper into something if I feel like we're moving too slow. But don't be afraid to interrupt me and tell me you don't understand, and we'll figure things out. So starting off, what is, yes?
Before you get there, there's a really awesome website that really taught me a lot about Git. It's literally called GIT branching.
It's on the last slide. I want everyone to go through that. Yeah, it's a really cool thing. I'm actually show you some visual things like detached head through that, because that lets you display things live. So Git is a distributed version control system. Version control system means that it backs up your files and gives you some sort of data about when certain changes were made and why they were made. The distributed is really important because prior to Git, most version control systems were centralized. This means you had to have internet access or intranet access to the central server to check things in. So if you wanted to commit a new file, you'd ping the server, say like, hey, I want to put this file and change it into the repository, and it would be moved there. Git is distributed, which means you have a local copy on your machine, and you can commit everything there. That means if you're working on the airplane or you're working in the dorm and you don't have an internet connection, then you can still make commits, keep your version history, and then push them to a remote server later. We'll talk about how to do all this as we go along. But yeah, so everything runs locally, and then you push things to move it to the remote location, which in our case is generally going to be GitHub, but there's other alternatives like Bitbucket or even hosting your own Git remotes. So when you're working in Git, files are generally in one of 3 sections. They're in the working directory, which is what everything that you generally touch if you're not using Git is kind of in the working directory. This is your directory, your folder on your computer where the files exist. Then there's a staging area. This means that the file's been modified, you've acknowledged it's been modified, and you said you want to take a snapshot of it to move it over into the Git directory. The Git directory is the versioned history of everything. So we'll be moving files between the working directory, staging area, and Git directory. The first way we move from the working directory to the staging area is to stage our files. We use the git add command for this. So whenever you go through the mindless motions of git add all, git commit, what you're really doing is moving those files from the working directory. You've modified those files. They've been in the working directory, the directory that you're used to working in. And you're moving them into the staging area. You're preparing them to be committed, for a snapshot to be taken, so that you can commit and move over into the Git directory, your versioned history of everything. And then, since you have a history here, you're going to want to sometimes go back to previous versions of your history, go back in time to old files. And to move files from the Git directory into your working directory so you can modify them, you use GIT CHECKOUT. So that's switching branches, that's going to previous commits and stuff like that. We'll talk about all this in a little bit more detail, but I just want to visually show out the different stages you can move between. Then even more in depth, you've got a couple different file statuses that files are going to move between. Untracked is where every file starts. Untracked means that Git doesn't know about this file, Git doesn't care about this file. Then there's unmodified. This is a tracked file that hasn't been changed since the last commit. Modified is a tracked file that's been changed but hasn't been staged yet. And then staged is files that are prepared for commit to be moved into the Git directory. So we go from unmodified to untracked by using git rm, git remove. So sometimes you'll accidentally put a file into a commit and then realize you don't really care about it anymore. You can delete this file locally, but if you want to keep a local copy and still remove it from the Git server, you can use git rm. Then you can move from unmodified to modified by just editing the file. There's no git command for this. This is just working with the file on your file system as usual. Then stage the file to move from modified to stage like we talked about, git add. And then you can move from untracked to stage, it's just git add. So you go immediately to stage when you do git add, if it's untracked. And then you move everything from stage to unmodified again by committing, because you take that snapshot, then we're back in the unmodified state. So we've been talking a lot about git commit. Let's take a look at how this looks. You start with an empty folder. You do git init. It creates a Git repository. There is no history at this point. You've just created a hidden folder called .git that has all your git config and stuff in it, but no actual commits. So our first commit happens. We do git commit -m, and we create a commit. We're going to be using a notation of C for each commit, and then the number of the commit is going to be just a single number instead of long commit hashes, because it's a little bit cleaner. So C0 is our first commit, and when we commit, we're automatically on the master branch, and there's this thing called head. I'm going to be putting head in these diagrams right now because it's important, but don't worry too much about what that means until we start talking about branching and moving your head to different places. So we've made some changes. We've committed it. We have our first snapshot. We move on, make some more changes. We git add to move them into staging, and we commit again. This creates a new commit, this time C1, and it moves master and head to point to that commit. Git is actually being really efficient. Between these two, it's just storing file diffs. So it's not storing a brand new copy of the file. So if you only change one line, it's about one line worth of data that's being saved in there. Or if you remove a line, it's about one line of removed data being saved in there. So Git's relatively efficient for text files, for keeping diffs and keeping the Git repository to as small of a size as possible. So we commit again because we make more changes. What's going to happen? Can someone tell me? So we're on the master branch. We just want to commit again. So yes. Yes. So now C2 is going to appear, and then master head's going to move over. And we've started creating this history. So a timeline of everything that's gone on is useful. That will help us. That's about what Dropbox gives us if we were to use Dropbox. But sometimes we want to work on two different features at once. We don't know what feature we're actually going to use. So in that case, it's going to be useful to have branching timelines, to create a new timeline, divert onto that timeline, save commits there, and then decide from there whether we want to put that into master or our original timeline, our main timeline. So let's talk about git branch and checkout, or creating parallel timelines for us to use. We're going to start off with what we had before. So we made 3 commits. We have some changes here, but we're only on one branch. So first command you run to make a new branch is git branch, then the name of the branch, what you want to call it. So we're going to create a new branch called develop. We've been on master. This is going to be our main branch. It's common practice for it to be called master. It's the default. Don't change master unless you have a really good reason to change the name of your default branch. But I want to make a develop branch. This is where I'm going to go and test out new features and kind of work on side projects. I'm not at the point that I want 5 branches, one for each new feature. I'm just going to keep a develop branch, keep things simple for now. So I'm going to put git branch develop. So between these 2 slides, master head stays there, but we've got a new pointer. This is called develop. What this means is the develop branch exists, and the develop branch points to the same commit, so it has the exact same history. Because the way this works is C2 points to C1, points to C0. So the history is this line here. Develop's pointing to the same as master, so it's got the same history. They're exactly the same right now. But head is still on master, which means that we're still working in master. So any changes we make to the working directory, any commits we make from here, will be on the master branch. We have not switched to this new develop branch. We've just told Git we want it to exist. Do you have a question? Yeah, so if you use git branch, it's never going to immediately check out the branch that you create. There's a shortcut for that we'll talk about a little later on. But from here, we've got to manually check out this new branch develop. So our next command we're going to run is git checkout develop, and you're going to see head move from master over to develop. So head is on develop, which means that our working directory is looking at files and develop. If we make changes, we make commits, it's going to be on the develop branch, which means only develop will move. It's not going to update any of the history for master. Master is going to continue to point to C2, but if we make a commit here, then develop's going to move over, and there's going to be a C3. So let's go ahead and do that, git commit. And now we've got a history. They share a common ancestor, so everything up to C2 is the same, but develop has this new information, C3, that's not located in master. So I've tested out my new feature. I want to go back to the master branch and go back and work on core features that I know we want in our products. So I'm going to go git checkout master. What's going to happen when I do git checkout master? Yes, so head's going to move to master, which means all the files are going to get reverted back to C2 in my working directory. So any changes I made in C3, like say I add a bunch of new files, to me in my file system on OS X, in my file system on terminal, the visible files are going to disappear, all those new files I added in C3. But they're still going to exist in that hidden directory .git because we still have this history here. It's not going to mess with any of our version control history. It's just going to change the files back to, so we go back to our snapshot C2. So let's go ahead and do git checkout master. And then head moved from develop to master. So now we're working on master, and there's a huge bug that I realize. Everyone's able to buy my app for free, or get all my features for free from my app because I forgot to disable developer sandboxing on my purchases. So it was just testing the purchase, even my feature release version. So I want to make a new commit that fixes that, takes out the debug sandbox, and actually charges users for the premium features on my app. So I'm going to make those changes, then I'm going to git commit. When I git commit, what is going to happen here? So git commit moves things that are in the staging area to a commit. So we're assuming that we've already staged our files and stuff. Yeah, no, that's good. C4. OK, where is C4 going to be? It's going to be pointing back to what? C2. Yes, so we're going to create a new commit, C4, and it's going to be pointing back to C2. So git commit. C4 exists, it points to C2, and our master and head both move to C4. Now we're in trouble. We've got divergent timelines here. How are we going to fix this? Are we just going to go check out, develop, and copy our files over and then commit them into a separate directory, check out master, paste them into the working directory, and commit them on master so we can continue to develop on master? No. In Git, we've got two features for fixing these problems, git merge and git rebase. Git merge is the most commonly used one. We're going to look at that first and show what that ends up making. In general, you're going to use git merge. Git rebase is a way to keep your timeline a little bit cleaner, to basically rewrite history so those branches don't exist. We'll look at git rebase right after we look at git merge. Yeah. So git merge. We want to join our branches back together. To remind you, we're starting off here. We've got two branches, develop and master. Our head is on master, which means that our current working directory, all the files we see are on the master branch. We don't see any of those things that we put into C3 on develop before we went back and fixed our purchase bug. So since we're on master, we can literally just call git merge develop. What that's going to do is look at C3, grab all the changes from C3 that have changed between C2 and C3, and try to apply those changes to C4. And what it's going to have to do is create a new commit that points back to both C3 and C4. And then it's going to move master head down to that C5, that new commit that we're making. So let's take a look at that. Git merge develop. And that's grabbing everything from develop, which is currently pointing to C3. So if we had more commits in here, it would grab all the commits between here and the place that it branched off from. But we only have one. So it's going to grab everything from C3, try and apply it to C4, and create a new commit that is merging those together. So when we use git merge, we merge into our current branch. So in this case, it was master because our head's on master, and we call git merge develop because we want to take the changes from develop. Does that make sense? Yeah?
What happens if you have conflicting edits?
We're going to look at it. I'm going to do a live example of conflicting edits, show you how that happens. Yes, so git merge, most of the time will work auto-magically. It'll be really great. It's going to go and just kind of put all the files in together. Sometimes two commits are going to change the same file, and Git's not going to be able to figure out, did you want this line or that line, or did you want both lines? So we'll take a look at how to fix those merge conflicts, as we call it, after we look at rebase. I'll pull up terminal, and we'll do a live example or try and get something that makes sense. So we're on master. We've pulled in all of our changes from develop. A couple weeks later, or a couple days later, we want to do some more test features. So we want to go back to our develop branch because we're not sure if we're going to keep these. The problem is develop is not in sync with master. Develop's still pointing at C3. It doesn't know anything about those C4 changes. If we're going to be developing new experimental features, we probably want those core features that we put on in C4. So we need to move develop to point to C5, and then also git on develop. So we're going to start out by checking out develop. We're going to do git checkout develop. and that's going to move our head from master to develop. So head is now on develop. All of our files, everything we see is the perfect snapshot of C3. So how are we going to get the changes in C4 and basically just move develop over to C5? Any ideas? All right, so if we call git merge again, then it's going to try and git merge master is going to try and take all the changes of master that aren't in develop and apply them to develop. Since C5 now points back to C3, where develop is, it's going to be really easy. All it's going to have to do is just move this pointer, this develop and head pointer, over to C5. So if we call git merge master, then that just moves over. No new commits or anything because it already knows how you want to resolve those conflicts. Does that make sense? So to sync things back up, you check out the old branch, the thing that's not up the sync, then you merge into the new branch that is further up the history. Yes?
Can you just move where the branch points to with git branch?
You can create a new branch if you want to, and so here we're on master head. If we wanted to make like develop, develop motion controls, because we wanted to test that out, we wanted a new branch feature, then we can just say git branch develop motion controls, and since head is at C5, it's going to create that new branch at C5. Does that make sense? If you want to take a look at a specific like workflow and discuss the pros and cons, grab me afterwards, and we'll take a look at how you used to work with things and make sure that it works overall and go from there. All right, so we checked out develop, we did git merge master, and we got them all synced up again. So now we've got a complete history. We're at the same place. Things have merged back together. Our timeline is 1 again. So if we were working on master or develop, they would just start adding commits on top of C5. Things are relatively good, but if you look at this, this is kind of messy. We've got this weird branching like shoot off here. If you're working with multiple branches, it gets even messier because you've got stacks and stacks and stacks of things. So Git has this other concept of git rebase. Git rebase can be cleaner. It can also be very dangerous. So use git rebase sparingly. I want to show you visually how it works because git rebase was this black box for me for a long time when I was starting to work with Git. So I kind of want to just show this out. So git rebase's idea is it replays the commits on your current branch in order on top of the other branch. So let's take a look at that in action. We're going to go back to our diverged branches here, and we're going to try and do the same thing. Get both develop and master pointing to the same thing with a linear progression overall. So we're on master right now, and we want to go git checkout develop, move the head there, and now we're going to use the rebase command. It's going to be git rebase master, because we're on the develop branch, so we want to rebase master into develop. So what this is going to do is take C4 and basically point develop to C4 for a second, and then add C3 on the end of C4. So let's take a look at that in action, and then we'll talk about some caveats here. So git rebase master, and that C3 just moves over to the edge of C4. So in case you missed that, when we do git rebase master, we're on the develop branch right now because head's there. We do git rebase master, and that C3, or all the commits that are on develop that aren't on master, get replayed or added behind where master was. So further down the timeline than where master was in the future of that. Does that make sense? Questions on rebase and like that little movement here. So we're on develop, and we call git rebase master. Instead of creating a new commit C5 here and merging them together, it tries to replay the commits on top. There can still be merge conflicts in here because it's going to sometimes not know how to fix this, but it moves it over to the end. Yes?
Does it still merge the code from C4?
Yes. Since basically it says C4 is our new area, now let's replay all the commits that aren't already on master on top of it. So it moves C3, it starts at C4 and tries to apply the C3 diffs to C4. And you'll sometimes run into merge conflicts in rebase as well, and you'll handle those the same as you handle merge conflicts with git merge. So this gives us a nice timeline. It's a little crooked right now because I couldn't figure out the animation to make it one seamless move over, then move down. So we're just going to clean things up. All that is go in from here and straightening things out again. No changes there. So when we called git rebase master, if you remember, C3 was C3 before. Once it moved C3 behind C4, that little prime tick showed up. Did anyone catch that? Anyone have an idea why that might be?
It's not the same all of the same manual.
Yeah, so this commit has been moved to a different place in history. It's been moved along in our timelines, which, if you've seen any sci-fi movies, you know that means history's changed to some extent. Any little thing that we go and mess with it, history's changed. We can't assume it's all the same. So Git's going to give you a new commit hash. We'll look at commit hashes soon, but they're just long little hashes of letters and numbers. So that C3 prime, it's still the contents of C3, but it's got a new identifier, which means if you try and push this to someone else's branches, it's going to give you errors. It's going to be really unhappy, which is why Git rebase is dangerous overall. You've got to be very careful when you rebase. You don't want to rebase on a branch that anyone else might be using. So this means in public code, if you think other people are watching your code, don't use Git rebase. Yes?
Could you give us an example of a reason you would want to rebase something like that rather than just?
Yeah. So this timeline, this history is a lot cleaner than the previous one that had that weird branch hiccup. So if I'm developing in private and I know for sure on our website team I'm the only person working on a specific feature, then I will develop on a branch. I will still push to my repository, remote repository, but before I ask to merge all those into master, I might rebase everything so that there's not these weird like random little hookoffs. Because on like a year's worth of website development on the same website, you're going to be making a lot of branches, and the history is going to get really ugly really quickly if you're not careful. So Git rebase allows you to keep that under control.
Is it normal to use that before you push it back to the master for everybody to get access to it?
It is normal when you're doing small features and there's not a lot of time, there's not a whole lot of changes between master and here. So if you're working on a fork that like Cocos 2D, the game engine that we teach or whatever, has Cocos 2DX, and that was kind of a fork and rewrite, you would not want to try and rebase those changes into the Cocos 2D we use because there's so many changes since they started like 2 years or probably like 5 years in between each other. You would never, you want to use a merge so you can say, this is the history, this is how it was developed, and in those 3 months or years that it's been branched off, we've merged it here at this point. So it's kind of a judgment call. Use git merge if you're unsure, but Git rebase is really important because a lot of development teams will have very particular workflows, and they'll expect you to be able to use those workflows. So I'm explaining it right now because some teams will be rebase-only teams and want to have a singular timeline without any branches on their main master branch.
Is there any problem with having branches like long ago in your timeline?
So like, you're saying if we had a bug fix branch that was like pointing here, is there a problem?
You just have a development branch off and then remerge and have it.
Oh,
Doesn't have any
there's no problems other than readability when you're trying to figure out later on like what's going on. Because if you're looking at like 40 branches, then things get really messy really quickly when you're trying to figure out what was happening where. So generally when you rebase, you go back and you end up deleting this develop branch. So it'd be for a very specific feature, and I rebase it in, merge it into master, then I get rid of the branch and pretend it was never put on another branch. So that when people look at the history, they just see a nice linear history overall. Okay, so we've accomplished the first step of our goal. We've got develop, knowing about the changes made in master. Now we got to catch master up to develop. So we're going to do git checkout master. That's going to move our head from develop to master. And then we just do git merge. So it's git rebase, git merge. I don't know, honestly, what would happen if you try. It's going to get really weird if you try and rebase, I think, at this point. Just do git merge, and that's going to move it over, because they have one straight history from master to develop, so it just moves the pointer over when you do git merge. More questions on rebase. My policy for rebase is understand what it does, go through the exercises that are going to be on the website I give you, and don't really worry about it until you start working on a group project like the Rails project later on, and then you as a team will decide what sort of workflow you want to use, and that'll give you some practice. You might not get practice with rebase until you join your first team that has a rebase-only policy. And I just want you to be aware of what rebase is and not have to say, I've only used git merge. What is this rebase voodoo magic? Yes? Yes. So here we're on develop. if we just did git merge, if we did git merge, we'd only be changing develop right now. So we have to move our working directory and move everything over to master. So we git checkout master, and then we merge because we want to modify master and get master caught up. If you did git merge master from here, there's no changes on master that aren't already in develop, so it's not going to do anything. I don't know what error message or what it's going to tell you, but it's not going to do anything functional. So we check out master, and then we git merge develop, and that moves the pointer over. So, like I said, never ever rebase a public branch. This is a branch that you think someone might be watching, a branch that someone else might be working on. Try to only use rebase if you know that you're the only person working on the project, or you know that the team has a rebase policy and no one's going to be touching anything on that branch. Because it rewrites history in a way that changes your commit messages, or your commit IDs, so you won't ever be able to push that rebase version to the remote repository since the history has been rewritten. If it's already there and other changes have been made, then you're just going to get conflicts and you have to do a force push or something like that, which is a big no-no. You never want to do that. That's going to end up rewriting anyone else's history that you don't currently have. So never rebase a public branch. You're going to anger the programming gods. Just seriously don't do it. Trust me on this one. You'll get people yelling at you. Like I've had huge fights with friends who've messed up public Git repositories we're working on, and it's no fun to be like trying to fix those issues late at night when you're just trying to get a feature done so you can go to bed. And that's always when it seems to happen, because people are trying to go through and just quickly get their stuff done as soon as possible, and they're not thinking. Keep this in mind. Keep the image of me staring at you and saying, don't do it. Have that pop up into your head when you're trying to do it. All right. So someone asked what happens when there are conflicts in files. This is called a merge conflict. Even when it's on a rebase, it's still called a merge conflict. So how do we deal with those merge conflicts? When you do something like git merge master, it's going to say something along the lines of auto merging file 1. So file 1 was changed in both branches. And it's going to say merge conflict failed in file 1. It's going to tell us that automatic merge failed. And then it's going to say, this is your problem. Fix the changes, then do git commit, and we'll move on. But you're going to have to decide what's going on because I can't tell. So if we were to do cat file 1, which just prints out the contents of file 1 into the repository, what we're going to see is this line here was all that was in our develop branch, and then this line here was all that was in our master branch. But Git was nice enough. They did say it's our problem, something we need to fix on our own. But it was nice enough to say, hey, this is what you're trying to merge into what. And it's going to give us this, and we're going to have to go through and decide what's going on. So in my case, I've decided I want just this line here. It couldn't tell that I wanted that because of the way I branched off. But what I do is just delete these 3 lines and this line up here, save the file, git add the file so we can move in the staging, then git commit. And it's going to automatically suggest that I use a commit message of merge master into develop or whatever branches I'm working on. So let me pull up terminal, get it on the screen, make sure it's readable, and let's go through this little scenario here and show how we do that. Yeah, and then current branch is the things between head, because we know that head is our working directory, what we've been using with. We've seen that in all the examples. We're pretty used to that now. And then what the branch that we're trying to merge in this case master, is under the equal signs. So let me pull that up and let's get started. All right. Can everyone see that? Big enough? Yeah. All right, so if we do ls, there's no files there. For those, hopefully everyone's comfortable enough with Linux now, or Unix now in terminal, or you went to Alan's lecture yesterday and you're still catching on, but ls lists the files. We can do ls a to show any hidden files. We know there's not if there was a Git repository initialized already, there'd be a .git folder there. But we can check that by saying git status, and Git's like, yo, there's no Git repository. What do you want? So let's create a Git repository. Does anyone remember the command for that? Git what? OK, so I hear git add. Git add moves files from the working directory. So now if I do git status, it still says on branch master. Why is that? Yeah, so git branch and then a name only creates the branch. It doesn't switch to it. We can use git branch with no arguments to list out our branches. We can see we've got the master branch, and we've got a new branch. The master branch has a star by it, though, so that means that we're currently on the master branch. Same with git status. It tells us in plain text that we're on the master branch. So to switch over, we're going to use git checkout new branch. I'm going to put this in a slide. I have this in a slide later, but you could do that all in one line with git checkout b new branch. Git checkout b new branch does git branch new branch, git checkout new branch. It's the two commands in one single line. So if you know you want to immediately go to the new branch, you can do that all in one line. Keep that in mind, but being explicit is sometimes good for learning. So we're on new branch. Let's go ahead and modify file. So some of you have preferred text editors. Some of you are Vim people. Some of you are Emacs people. We're not going to get into that fight right now. I'm going to use Nano because Nano has the shortcuts on the bottom. Okay? And I'm going to recommend that people who are new to using terminal and stuff use Nano. I'm going to show you how to change your config file so that it only brings up Nano instead of Vim. If you have no clue what any of these means, there's a holy war going on between Emacs and Vim users. Don't get involved in it. Check out both of them later on your own time, or if a team tells you you have to use them. For now, use Nano. It'll keep you moving faster. All right, so Nano opens up file. We've got nothing in there because we created an empty file. So we're going to say this is from commit 1 on new branch. So on the bottom here is all of our shortcuts to get out of this. What I want to do is exit. The little caret means control. So I'm just going to hit Control X. It's going to ask me if I want to save the changes I've made. I want to save the changes. I made the changes for a reason. So I'm going to just put Y in there. I'm going to press the Y key, and it asks me what I want to save the changes as. I want to rewrite over a file because I just want to save them to file. So I'm just going to press Enter. Cool. So if we do cat file, cat is a command that prints out the contents of the file. We can see that the file is currently what we just put in there. So this is from commit 1 on new branch. Git status. We'll see that it's modified but not staged yet. So what do we have to do? Well, we want to commit, but we need things staged before we commit. Git add, yes. So we'll do git add. This time we'll do dash dash all. Git status, just showing you that there's no difference in there. Yes? So period, if I remember correctly, will not remove files that you deleted from your local system. So if you deleted a file and you use period, that file delete's not going to get pushed up to your Git repo. So if you put some embarrassing picture in there that was tracked and you want to delete it, you delete it and use dot or period, git add period, then it's not going to send that delete message up to the commit history, and that file is still going to exist. Yeah, so dash dash all or dash capital A are both the same thing, and it's more inclusive than just period. All right, so we've added it. We see in our status that's in staging, ready to be committed, because it says changes to be committed. Now we can do git commit dash m commit for new branch. I'm not following my own rules, so change for new branch. All right, so git log. We'll now see when we git log that we have on the bottom, the lowest down is the furthest back in history. Create file, then we change file for new branch. If we do git branch, we can check what branch we're on. We're on new branch right now. So we've created a change on new branch. Let's go back on master, create a conflicting change, merge in, and solve the merge conflict. So I'm gonna go through this a little faster this time because we're doing pretty much the same thing. Just git checkout master. All right, so now if I do git log, there's only 2 commits. It's only showing us the commits that are currently on the master branch. I'll show you how to get more verbose logs that have like little branching diagrams a little later. But right now I've got it shortcut to that. So that's a long command. I'll show you how to make an alias for that if you want to use that. But you can see that we've got create file. We've got our change for a new branch that we created first. then we've got change for master. And it tries to do this little branching diagram there. You see it's branching off with the asterisks being individual commits. And what we want to do is merge those back into a new commit, a fourth commit, and have those connected to each other again. So we're on master. Let's go ahead and merge in new branch. So git merge new branch. We've got a merge conflict. So Git's telling us to fix it. It's your own problem. We can do git status. And it actually tells us not just that there's changes to files, but there's unmerged files. So you can open this in whatever your favorite text editor is, Xcode, Sublime, Nano, Atom, Vim, Emacs, whatever. I'm going to use Nano so we can stay in terminal. So I'm a Nano file to open file. And this is almost exactly like the slide. We've got our changes from the head, which is currently the master branch, on the top. Then our changes from new branch on the bottom. So in this case, to fix this, we actually want both of those lines in there. So all I'm going to do is actually just go through and delete all this extraneous characters that is marking out everything for us. So go through and delete it. This looks pretty clean to me. This has the history that I want it to have. So I'm going to go ahead and save it. And we can cat the file to view the file. And this is clean. This is what I want to have overall. So how do I tell Git that it's been fixed now? Yeah, so if we go back here, fix conflicts, and then commit the results. So if we try and do git commit now, it's telling us there's an unresolved conflict. So how we mark the conflict as resolved is just git add. And now if we do git commit. So if you do git commit without the -m, then it's going to open your default text editor, so you can write out your commit message in the text editor. So if you want to have a very detailed commit that's going to be longer than 50 characters, create a subject title that's 50 characters long, do 2 enters so there's a space in between, then put a body in there. And then GitHub and other editors know how to handle that so that you can have that detailed there. The other time I recommend using just git commit without a -m is when you're fixing merges, because it's going to auto-populate with merge new branch, which is what I want to. Merge branch new branch, which is what I wanted to say. So I'm just going to save this by exiting it. And now we can git log. And we see that we've got our change for master, which is our second commit, then merge branch, new branch. So we now have a complete history. And we've also got change for new branch and create file. If you git log and you've got a long history, so more than like 5 or 6 commits, you're going to get this weird thing where you can scroll through it and you've got the little colon at the side. This is technically like Vim of some sort. To exit out of this, just hit Q and it gives you your terminal back. Don't panic, just hit Q. Ask a friend, an instructor if you forget. Yeah, a lot of people get confused by that. So let's actually, so I'm going to go check out new branch. And then I'm going to merge, git merge master. And then this fast forwards, so it just moves the pointer over. And now we can do git log, or one line log. And now we can see that we used to just have these 3 commits. We now have the 4th commit, and there's the little slashes telling us that it's merged back in there. Everyone cool on merge conflicts? Yes? That is a shortcut that I'm going to show you how to add, but it's git log one line decorate graph all. So it's just got like the whole command --1 line --all and all those things that I was saying, but it's a lot easier to type out git lol. So I'll show you how to add aliases at the end of this so you can save some keystrokes on common commands you're using. Is there a question over here? So you use git add. So if you do git add --all, it's going to add any changed files or any files it doesn't know about. But if you just do git add, then the file name or the path to the file from there, then it's only going to add that one to the staging area. So you can just commit that one. What? All files that are under the main directory. So right now I'm in a folder called test-git. So if I create new folders in test-git, and I do and add files to that, and I do git add --all, it's going to go into all those subfolders, grab all the new files inside of there, and then when I git commit, it's going to snapshot everything in there. But if I only wanted a specific one, then I can point that out specifically. Does that make sense? Yep. If you want to look at like some specific examples later on, grab me. Cool. So I've showed you how to fix a merge conflict. It was a very simple one. You will get some ugly ones with iOS later. We'll talk more about how to deal with those and avoid those as much as possible. Sometimes there'll be multiple files you've got to fix, but it's the same process. You just open up each file that needs to be fixed, grab what information you want to stay in the merged commit, and delete everything else. So let me turn off. All right. So merge conflicts happen in both merges and rebases. They're always called merge conflicts. You've got to resolve them, git add those to mark them as resolved, then git commit to complete that and add the new commit in there. So let's move on. Oh, and at the end of a rebase, since rebase doesn't have a commit that puts them all together, it just replays the history. Instead of git commit for the final command, you just do git rebase -- continue. Git will tell you that, so always look at your output. The output is really useful and is generally going to tell you exactly how to solve the problem. So rebase -- continue or git commit in the case of merge. Questions before moving on? Cool. So let's start talking about remotes or sharing and backing up. This is going to actually apply the distributed that we talked about in this distributed version control system. All the Git we've been showing you and talking about right now has all been local. We've never pushed it to another place to actually distribute the code further. Yes? So you can delete the branch if you want to go through and clean things up. It depends on how your workflow is. If you just have like a develop branch and a master branch where master is functional code that's going to be used in release and develop is code that's not quite functional yet, not quite where you want it to be, then you don't ever have to delete that develop branch. But if you're making a new branch for every single feature you create and trying to use like that sort of rebase git flow methodology, then yeah, you'll generally delete the branches at the end. But we're not going to actually do a live example of that. So let's get distributed. Git remotes are non-local copies of your repository. They might actually exist before your local copy. So in the case of the Python Twitter bot project you just started on, your Git remote was created before your repository and you use git clone to copy it down to your computer. So it takes that remote, copies it down to your computer, and every time you use push, it's going to copy the code back up to there. Every time you use pull, it's going to pull code back down from there. So right now, you're not really working on group projects, so you won't be using git pull. But we're going to start doing code review in line on your files, which means you're going to have to git pull after we push those changes to your remote repository to get those code review changes that we've made and those comments that we've put into your code telling you what we think and how you should better format things. So push is moving code from local to remote. Pull is moving things from remote to local. Yes? Yeah, so in general, we're going to do comments in the file. We might have like a code review file that has more broad overview stuff. We'll talk about that more later. But the point is, even though you're not working on a group project, technically, you will still have to use pull very soon. When you do git pull, that's another time you're going to run into merge conflicts. And it's going to be the same process as if you tried to merge branches manually. But what it's doing is taking the code from the remote branch, copying that remote branch to a hidden copy of a branch on your computer, and then running git merge on there. So if you've got 2 local branches and both those branches are remote, technically you have 4 branches in your computer. You just don't really touch the other 2 remote copies. Does that make sense? Yeah, so you'll run into merge conflicts because a git pull is technically a git fetch and a git merge. And we'll talk about that in a second. The reason you want to use git remotes is because, for one, everyone here is using laptops. This is San Francisco. You leave your bags around, your bags might get taken. It's not raining right now, but when it starts raining, it's probably going to catch you all by surprise. Your laptop might get wet. You might lose your hard drive. Something at some point in your life is going to happen to your computer, and you're going to lose everything that's not backed up. So Dropbox works really great for photos and stuff like that. GitHub and Bitbucket work really great for code. In addition to that, it allows for collaboration. So the whole open source movement completely relies on distributed, or version control systems in general. They don't have to be distributed, but most of them nowadays are, because it allows a massive amount of people to collaborate on the same thing, but still gives write access control to the owners of the repository, to the people managing the project. We'll go more into that in another lecture, because the whole forking and stuff like that is kind of involved and already taking a long time. So git push moves commits from local branch to a remote branch. The syntax is git push, then the remote name. If you only have one remote or you clone something from GitHub, it's going to be called origin. That's generally just like the common practice. Once you start adding other remotes, then you can say, okay, I want to push to this version on GitHub, but I want to push this to this private version on Bitbucket that I have. So remote name and then branch name. So in this case, it's generally going to be git push origin master. So let's take a look at that in practice. On the top, we've got our local copy. You've been used to seeing this. This is our example from when we were talking about commits. On the bottom, we've got origin master. So what happened here is we created our Git repository, added some files, made commit 0. Then we git pushed. We pushed that code up to origin master, and GitHub knows about that. Then we got in an airplane, started working, made 2 more commits, and now our branches are out of sync. We need to push commit C1 and C2 up to origin master. So what we run is git push origin master, and since this is all linear and they match each other up to C0, it's going to successfully just add in C1, C2, and move the pointer over for origin master to C2. Questions on that? Cool. So git pull moves commits from, oh, that's wrong. From a remote branch to a local branch, it's really a git fetch followed by a git merge. And then you also have an option of using rebase if you want to use a git rebase instead of a git merge at the end there. So if you use git pull without the -- rebase, it's going to call git fetch, git merge. Git fetch goes and copies those remote copies of those branches down to those hidden local copies of the remote branch that we talked about. Then it calls git merge on your branch to that local copy. So it moves all the code down and then merges in. If you do -- rebase, it's going to call rebase instead of merge. So let's take a look at an example of that. In this case, we made the initial files. We made commit 0, pushed that up to GitHub. We went out, had some fun with some friends, but our other friend was continuing working on the project. So they made changes C1, C2, and they pushed those up. Now, we want those changes. Those changes are useful to us, so we want to pool. So we git pull origin master, and it's going to move commit 1 and commit 2 down to our local master branch and move the head over. Very simple. But these are very simple things where only one of the two changed at a time. Only the local changed or only the remote changed. What happens when there's merge conflicts? When someone changes the remote, you change the local, and you try and push. Well, the push fails. You've got to pull first, which is going to git fetch, git merge, and then you can push that all up. Let's take a look at that. So changes on the remote using git pull. So both of these are linear, but if you look at the end, we've got C4 on our GitHub branch, on our remote repository. We've got C3 on our local repository. So when we git pull now, we're going to have a merge conflict. So let's go ahead and git pull origin master. So git pull origin master adds C4 in there. And if there's a merge conflict, it's going to ask you to fix the merge conflict. You're going to fix the merge conflict, git add, git commit to mark those changes as resolved and make our new merge commit. It's going to add C5 in there, merging those two commits together, and we're going to have our master head there. That make sense? So now we know about the remote changes, but GitHub still doesn't, our remote GitHub repository still doesn't know about our local changes. So from there, we've got to git push origin master, and that's going to add our C3 in the side there, add our C5 commit, and since they both point back to each other, it's going to be able to fast forward those changes. So let's take a look at that. C3 is added, C5 is added, and the branch is updated remotely. Oh. C3, C5. And that last little dissolve there is because this was linear and that was linear, these two were switched, but there's literally no difference other than representation of making those match. So our branches are matching. They're all pointing at the same thing. Does that make sense to everyone? You resolve merge conflicts in the same way as you resolve local merge conflicts because it's technically a local branch that's been copied of the remote branch. So everything works the same. So what about changes on the remote when we want to use rebasing. So you can use this git pull -- rebase. Again, be very careful about this. It has all the same downsides as rebase because it does git fetch, which updates those hidden branches, and then git rebase to rebase instead of merge at the end. So let's take a look at that in action. Same as example as before. We have our C3 locally. GitHub, our remote repository, has C4 from a friend. And we want to pull those changes in, pull those changes down, rebase them in, and then push everything up so we have a nice linear timeline. So let's go ahead and do that. Git pull rebase origin master. It moves C3 over, puts C4 in, and then moves the head over to C3. And again, that C3 is C3 prime. It's a modified commit hash. It's not the same, so be careful. You are rewriting history here. And now we can literally just do git push origin master, and that's going to add C3 prime into GitHub and move that over. So that allows us to have that nice, clean, singular timeline rebase history that some teams want you to have when you're working together. So we've talked about the whole Git flow of pushing and pulling, and we've talked about a lot of commands. I've shown you a lot of commands. These slides are mostly for reference, so I'm going to quickly run through them. If you have any questions about what I mean, please stop me. So git init starts a new empty repository. You run it from the base directory of the project. So in this case, if you were to create your own repository for the Python project, you'd create a Python Twitter bot folder on your computer, cd using terminal, change directory into that folder, then you'd run git init, and it would create that .git hidden folder there for you and allow you to start committing. Git status shows the current file status of the repository. It's useful for figuring out what will be committed, what you've already moved to staging, what you've changed and might want to stage before you commit. It's just an overall, tell me what's going on, Git. Tell me what you're thinking about. And just to remind you, the file status is tracked, unmodified, modified, staged. This slide was earlier on, but that's what I mean by file status. It's going to tell you what's been added to the folder that's not being tracked. It's going to tell you what's modified, unmodified, and stuff like that. Git diff is something I haven't shown you yet. Git diff allows you to look at the differences between what you currently have staged in the last commit. That's git diff stage. You can look at the differences between two commits. So you can say, give me commit 3 and give me commit 2. Tell me what changed between those. By git diff, then commit 1 is going to be the commit hash for commit 1. Commit 2 is going to be the commit hash for commit 2. And then you can also look at the differences between two branches. And this is going to give you, let me show you really quick, I guess. It's going to give you kind of like these pluses and minuses to show you what things have been added where. All right, so like we want to have the differences between these two commits. We do git diff first commit hash, second commit hash, and then it says that only one file has been changed. That's the file called file. And between the two, this red line, which you can't really see, has been removed, and that green line has been added. If you switch up those commit hashes, it's going to look at it from the different perspective, going from one to the other. Kind of up to you how you want to look at it, but just keep that in mind. So git diff will be really useful when you're trying to figure out, what was I thinking last night when I added that new bug in there? What did I actually change? You'll be able to look at those commits. This is why it's really important to commit often. When you finish a small feature and something's functional, commit it. Because then you can look at very granularly, when I said this code was supposed to do this, this is what's actually changed. And you can look at commit versus commit versus commit and kind of step down the history to find where your bug is. Git log we looked at. Git log shows you all the commits on the current branch. If you don't use any extra things, you can use it to find a commit hash. If the log is long, like I said, press the Q key to quit out of that and get back into the terminal. And then that special line thing I used to show up the graph, I'm going to show you how to alias that, but the whole command is here. It's git log, one line, graph, decorate all. So one line means that it compresses everything into the short commit hash, just the title, and I think the name. Graph means it gives you the little like branching graph on the side. Decorate might be color or something like that. And then all means it shows you every single branch, not just the current branch. Git add moves a tracked file to staging or moves an untracked file to staging. So it moves things in the staging. If it's untracked, it will continue tracking it after that. You've got a couple options with that. You've got git add -- all. You can do git add and pass in a directory or folder name. It's going to add everything that's a child of that. You can do git add on a specific file or a list of files. So if you wanted to add file 1 and file 2 in the same one-liner, you would just do git add file 1 space file 2. And then you can also use asterisks. They use wildcards. So if you wanted to add all text files in your root directory, then you can do git add *.text. And star in this case is a wildcard that could be anything. So anything that ends in .text is going to get added with that command. Git rm is how you stop tracking a file. And basically the file arguments work the exact same as git add. So anything you can do with git add, you can pretty much do with git rm, include removing a single file so it's no longer tracked, removing a directory so it's no longer tracked, or removing all text files so they're no longer tracked. Git commit is how we take our snapshots. You move all your stage files into a commit or a snapshot, and it adds that commit to the current branch, keeping our long timeline history. Keep your commits to 50 characters or less. Use the imperative or commanding tone. There's a nice long blog post that you should read through. And the biggest thing that I see in unprofessional developers, and I'm guilty of this all the time, our team is guilty of this all the time, is really bad commit messages. In our case, our commit messages are bad in the sense that they're not imperative mood. We sometimes capitalize, we sometimes don't capitalize, so there's no standards. They're not as bad as some of the student commit messages you see where it's just like, what the hell, or I broke everything, or hopefully this fixes this. I have no clue what this does. There's some really unuseful commit messages, and when companies look at your public repos later on, you're going to be embarrassed when they see that, because you know they will see that. And you're not helping yourself out at all when you try and fix things later, because you don't have that history. So even if you're working on a small project that's only lasting a day, if you have things in Git, get into the process of writing good, short commit messages. 50 characters or less, imperative mood, capitalize the first letter. That covers the main basics, but you should read that blog post. It's really good. It talks about some awesome commit messages. And yeah, it's kind of just, it's cool. All right, git branch. List the current branches with git branch, no arguments. Create a new branch with git branch and then the branch name. And keep in mind, git branch does not switch to that branch. You have to use checkout to switch to that branch. So moving on, git checkout. You can check out a branch name. You can check out a file from a commit. You can check out a commit. You can check out and create a branch at the same time. All these commands are listed. So check out and create a branch at the same time is git checkout -b, then the branch name. That's going to run git branch name, git checkout branch name. So it's just two commands wrapped into one, kind of like git pull. Be very, 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 very careful when you do git checkout commit. Pretty much every year at the Summer Academy, someone does that. They're looking at a previous commit because they know they've added a bunch of bugs in there. They start working on that checked out commit. And if you're paying attention to the log messages that terminal gives you, which are really important to pay attention to, you get this weird thing. You are in a detached head state. Has anyone seen that on their code? Yeah, so a few of you have seen that. Does anyone have any clue what that means? The head is pointing to where you're working on, but it's not currently on a branch. So I want to use that learn git branching to actually show you that. But your head is no longer on a branch, and that means the commits that you make get put into this kind of no man's zone of Git territory. They still exist on your computer, and they're sometimes possible to find before Git goes through and kind of starts cleaning things up to save space. But it's a really dangerous zone to be in, because once you check out, like say you're on develop branch and you check out an old commit, you're going to get into a detached head state. You start working there. If you don't ever put that on a branch and then you check out master, when you check out develop again, it's going to be back where it was because you never actually updated develop. So let's look at that. I want to show you visually what that means. All right, so I'm going to use this because it's got this really cool visual live editor. So So we're on master. We've got 2 commits, commit 0, commit 1. Let's go ahead and git commit a few more times. And in this, our commit hashes are actually mapped up to these C1, C2, C3. So we can do git checkout C1. Because we realized that the history they gave us is actually what we really wanted this whole time. So we're going to go check that out, make sure that that's what's going on. We check it out. If you notice, there was a little star next to master before, which meant our head was there. But when we checked out, our head is the only thing that moved. There is no branch attached to this. So if we continue to make changes here, git commit, it's going to tell you, warning you're in a detached head state. But the people who got into a detached head state and don't know what it is either didn't see that log message or they didn't think it was important. They thought the computer is just using big capital like exclamation points and stuff for no reason. Whenever your computer is throwing exclamation points at you, it's either a really annoying developer or it's really useful. So I would always read them and make the determination afterwards. And if it's talking about something you don't understand, Google it, please. You'll be so much happier if it's a huge error message that you need to be aware of if you Google it. So detached head state. We just talked about detached head state. We know it's a dangerous thing. So if we continue to git commit, now we've got C4 and C5. They're kind of faded out because those don't really exist in any sort of history. Now if we go to git checkout master, they're not really anywhere we can get to. There's a command called git reflog that will allow you to view all these hidden dangling commits is what they're called. They're commits that exist in the history but are no longer on any branches. So C4 and C5 are dangling commits. Git reflog will allow you to find those. So if you do screw up, you do end up in a detached head state, working there, never putting it on a branch, then you can find it with reflog, immediately seek help to get things back on, to get those dangling commits back in. Ask an instructor if you need help with that, but just be aware detached head states are not good. So let's fix this. Is that what you're going to ask? Yeah, so what we're going to do is, we made this mistake, we were ignoring the detached head state, so let's fix it. So we can go git checkout C5. And in this case, what we'd have to do if a student came up to me and said, hey, I was committing after checking out and all the changes are gone, they're not on my develop branch. What I would do is git reflog, which is going to show me all these dangling commits and just kind of ordered history of what time they were made. I'd find the commit hash and then check that out. So git checkout C5. Our head's moved there. And now we could just do git branch develop. And now our head and then we do git checkout develop. And now our head is on a branch. Those commits are no longer dangling. I probably should have used git checkout B so I didn't stay in that detached head state. If you notice before I did git checkout develop, the head and develop were pointing at the same thing, but they were separate, which means if I continued to commit there, I'd be making more dangling commits and I didn't fully finish the problem. Yeah. Questions on that? Cool. So hopefully this demystifies a lot of things about Git. So detached head. In addition to checkout, which just moves your head onto no branch and doesn't rewrite any history, just moves the head around so you can view old stuff, you've got git reset. You've got 2 options with git reset, soft and hard. Soft is a relatively safe change. So git reset soft head up caret is going to undo the last commit, but keep all those files from the last commit in the staging area. So if you realize, oh, I still have a bug in here, I haven't pushed it yet. Haven't pushed it yet is really important, because if you undo a commit, recommit it, then you've rewritten history. So if you've made that history public, then that's very dangerous, and people will be mad at you. So if you haven't pushed it yet and it's still local and you know you're the only one touching it, you can undo the commit, add in whatever file you forgot to add, maybe it's a resource for a button or whatever, and then recommit it so it's a single commit message instead of having to add a new commit message that says forgot file, which I know I've had to do so many times. Git reset hard is the equivalent of nuking history. Like it gets rid of that commit that used to be there and goes back to the previous commit. So be very careful when you're using either of these. Soft is to undo a commit but keep the changes ready in staging. Hard is to undo the commit and get rid of it. be wary of doing that. Yes?
Is there a preference between doing a soft reset and just amending your commit?
If you just want to, you can just amend the commit if you want to, yeah. The soft reset is more for when you're making, like you might have to work for a little longer. Yeah, so there's other ways to amend the commit and stuff. I don't want to throw too many workflows at you, but you can look more into the man pages and whatnot.
You don't specify between soft and hard.
What?
If you don't ask,
I do not know what it defaults to. I personally would not take that risk because even if I look it up now, I'm going to forget like a couple months from now. So something like this that's going to destroy my history, I'm always going to be explicit with. And I recommend you are too. Being explicit is always a safe way to go. Yeah. Cool. So, been talking so long, my clicker died. Git clone. This is what you, was there a question on reset? So if it's already been pushed to GitHub, you undo the commit and recommit something else. There is no way those trees can be merged easily, so GitHub's going to get mad at you, tell you it can't accept the changes, and you're going to have to force push or go back and fix that, so don't do it. Yeah. Yeah, you want to just make a new commit on top to like check out the old files or figure out a different workflow that makes a new commit on top saying I'm undoing this commit. Because if I had pulled that, then now we've got like 3 different copies of history and none of them can be easily merged. So be very careful when you push things. And if you've ever pushed it, do not go back and rewrite history if there's anyone else working on it. If you're on a team that says like this is your feature branch that you're working on alone, then you can do that even if you've pushed it and force push, but be careful. If in doubt, don't force push. Git clone, you did this on the assignment. It just takes the remote repository, copies it to your computer with the remotes already set up. So if you create your local repository, you want to add a remote, GitHub's going to give you the commands to do this, but it's git remote add, what you want to call it, which is always going to be origin by default. That's like the main name that people use for a single remote, and then the address to that. I recommend that you stick to SSH addresses. This will allow you not to have to type in your password every time because all of you should have set up your SSH keys when you went through everything yesterday or the day before. Git remote v will list the remote names and their addresses. Git remote show, then the name. So in like our case would be git remote show origin. Will tell me what branches are on origin and all sorts of information about origin. And then if you no longer want to use a remote because the repository is deleted or you want to set up a new one, cleaning up old stuff, whatever, git remote rm or remove will remove the remote. Git push, we showed you a lot about git push. We did some exercises up with the diagrams and everything. The big thing is if you want to delete a remote branch, git push the remote name, then colon the branch name, all one thing. So if you wanted to delete the master branch on the remote origin, it'd be git push origin colon master, all one word, colon master there. And this is something that's not going to be easily undone. So be very careful when you're doing this. You can anger teammates if you accidentally delete a main feature branch and they no longer have that history. So make sure you understand the team's rules if you're working on a team. And then GitHub, when you set up your remote, it has you set up the default as GitHub. So technically, if you git push, I think it will always try to push from your master branch to GitHub's master branch. I prefer to be explicit and do git push origin master or git push origin, whatever my remote branch name is, because then I don't mess things up. I'm thinking about every decision I'm making instead of relying on Git to do the right thing at the right time. So I recommend you're explicit as well, even if that's set up for you. Git pull, same thing as git push. It's git pull the remote name, then the branch you want to pull from. Then just a summary of the commit workflow, the basic workflow we asked you to use. It's git add all, git commit. So add all moves it to staging. Commit takes a snapshot of that staging area and saves it as a commit. And then you push it to origin master. So I've been promising you different config things. The first 2 you should have already done. Big thing to note is if you set your local Git username to something that's not associated with your GitHub account, so if you use like your MakeSchool email address and that's not added to your GitHub account, it's not going to track your commits correctly. So you need to either change that or add whatever email you've saved to GitHub. GitHub is just like profile settings, emails, or something. I've got like 5 on mine. You can add as many as you want. And then I recommend you do git config global color UI true. That's going to give you some more color and things, allow you to see the red for the deleted lines, green for the added lines, and branches look much better and everything. If you do not use Vim by default, you are new to terminal text editors, you need to go in and git config global core editor, nano, and this is going to give you nano. Nano is a lot less mystical. The commands shortcuts are all on the bottom for you. It's going to keep you moving quickly instead of getting bogged down by learning a new text editor. I do recommend at some point you check out Vim and Emacs and decide if either of them are for you in terminal-based stuff, but don't worry about that right now. You've got a lot going on. Focus on the essentials. And then these are 2 aliases that I'd recommend you add. So git config global means that it's happening in every single repository, so git for your system. Then alias dot the alias name. So if you remember before I did Lala, so that was git log one line all with the pretty graph and everything. That's because I already put in my put this config command. So it's alias dot whatever you want to call the command. So you can like have, I don't know, git hello alias to init if you wanted to. You can have git co alias to checkout. So this part here is going to be after the git command as if it were a default git command. Then here is the command that it's alias to. And this is going to assume that git's being run, so git's going to be appended to this. If you want to get fancy with that, and then you can look at the docs for that overall. These slides will be posted, so you can add these later if you don't get these down right now. Just keep in mind, if you're doing aliases with spaces in them, you need quotes because those need to be escaped. Then commands that I have not covered that we might talk about a little later if people are really interested, but you may hear about or see on the web. Git stash. Stashes the changes without committing them, because if you try and switch to a new branch,